Hello wonderful people, it's Medicosis Perfectionalis. Welcome back to my physics playlist. In previous videos we talked about an introduction to physics. We talked about physical quantities, the fundamental and the derived. We talked about scalars versus vectors, distance versus displacement, speed versus velocity. And today it's time to talk about mass versus weight. Mass is a scalar quantity, which means it has a magnitude only but no direction. However, weight is a vector, meaning it has both a magnitude and a direction. Weight is dependent on gravity, and gravity is always trying to pull you downwards towards the center of the earth, so to speak. When this plane is flying and cruising through air, we have four forces affecting it. Each force has a magnitude and a direction. Who's pulling me down? That's the weight, which depends on gravity. And this is opposed by the lift force. The engine thrust is pushing me forwards, and this is opposed by the air resistance or drag that is pushing me backwards. So weight is a force. It's a type of force that is always pulling me downwards. It has a magnitude and a direction, and it's measured in Newton as a measuring unit. Click the like button, click the subscribe button, and let's get started. Please try to watch these videos in this physics playlist in order for maximum understanding and retention. Not to be confused with mechanical retention. Only dentists will understand this joke. And besides physics, I have many other playlists, including anatomy, physiology, pathology, pharmacology, immunology, you name it. Physical measurements. We have physical quantities such as mass, such as length, such as time, such as weight, etc., etc. We have measuring tools and we have measuring units. Mass is measured in kilograms. 1 kilogram is 1,000 grams. Force is a physical quantity. What's the measuring tool? It's called a spring balance. And what's the measuring unit? It's called newtons. Physical quantities are divided into fundamental physical quantities and derived physical quantities. Fundamentals are fundamentals. You cannot derive them from anything else. They cannot be defined in terms of any other physical quantity. One example is time. Another example is mass. How about derived physical quantities? They are derived from fundamental quantities or from something else. For example, surface area is derived from length and width. Volume is derived from length, width, and height. Can someone tell me what's the difference between volume and capacity? Please comment below. Mass is a fundamental physical quantity. However, weight, which is a force, is a derived physical quantity. It is derived from the mass of an object and the acceleration caused by gravity affecting that object. How do we measure mass? We measure mass in kilograms. That's the standard unit. 1 kilogram equals 1,000 grams. But how do we measure force, including weight? Newtons. According to Newton's second law of motion, force, including weight, equals mass multiplied by the acceleration. If you're talking about weight, the acceleration is the acceleration caused by gravity, known as g. What's the measuring unit for mass? It is a kilogram, all right? And what's the measuring unit for acceleration? Meters per second squared. So we can measure force in kilogram times meter per second squared, which is equivalent to 1 Newton. So 1 Newton equals kilogram times meter per second squared. Next, scalars versus vectors. Some physical quantities are scalars, meaning they have a magnitude only but no direction. Conversely, other physical quantities are vectors. They have both a magnitude and a direction. Mass is a scalar physical quantity. It has a magnitude but no direction. On the other hand, weight, which is a force, is a vector, meaning it has both a magnitude and a direction. Weight is always pointing downwards towards the center of the earth. You can download these colorful notes at medicosisperfectionalis.com. I help you learn, understand, and pass exams. How can we define force? It's an external influence that affects the object to change its state of motion or direction. How about weight? Weight is a subtype of force, an external influence that affects you or the object to try to pull you down. What's the measuring tool for force? Spring balance, and the measuring unit is is Newton. 1 Newton is equivalent to 1 kilogram times meter per second squared. Mass times acceleration, because force, including weight, is mass times acceleration. Mass is here, acceleration is here. Do you remember Newton's 3 laws of motion? First law, second law, and guess what? Third law. First law, the sigma or the net forces together eventually will add up to 0. Newton's second law, what is force but the rate of change of momentum? And what is momentum but mass times velocity? So let's put mass times velocity here instead of momentum, and you end up with mass times velocity over time, just like this. Instead of the momentum, I put m times v. The sophisticated student will notice that delta v over delta t is what? That's acceleration. So it's as if we're saying that force equals mass times acceleration. Bingo! And this is the mathematical formula for Newton's second law. How about Newton's third law of motion? For each action, there is an opposite and equal reaction. If F is pointing towards the right, then the other force is pointing towards the left. I'll give this a positive sign and this one a negative sign. Positive or negative points to the direction and not the magnitude. The magnitude is presented as F. So don't forget this. Force equals mass times acceleration. If this force is weight, then it's mass times g, which is acceleration caused by gravity. And this is sometimes written like this. Force caused by gravity, aka weight, equals mass times acceleration caused by gravity. If you wish to see more physics videos in the future, drop a car emoji in the comments. If you wish to see more medical videos in the future, drop a heart emoji in the comments. Look at this box. This box is being pushed this way. So this is the applied force. Who's gonna counteract it? The friction force. Weight is always pointing downwards towards the center of the earth, and this is opposed by the normal reaction force, or simply normal force. How do I calculate weight? It equals mass times acceleration caused by gravity. So horizontally speaking, how can I calculate the net force, aka the moving force? Mass times acceleration in the x direction. But how about vertically speaking? Not horizontally, but vertically. How do I calculate the weight? It equals the mass of this box multiplied by, what is the name of the acceleration caused by gravity? G. And this is acceleration in the vertical dimension. And this is the oldest trick in the physics book. The question is, by ignoring the air resistance and then dropping a heavy ball and a light object or a light feather, which one will reach the ground first, assuming that there is no air resistance? Answer: both of them will reach the ground at the same moment. Why is that? Because both of them are influenced by the same gravitational acceleration, which pulls them downwards. And of course, both of them started at the same moment with an initial velocity that equals 0. They started from rest, and they will reach their maximum velocity, the final, the moment they hit the ground. Let's review the airplane again. The airplane is flying. This is weight, pushing it down. What's the opposite to that? Lift force. Thrust me forward, that's the thrust of the engine. Drag me backwards, that's the air resistance. All of these are 4 forces. Each one has a magnitude and a direction because force is a vector. When something is being dropped from a height, like this apple falling from a tree, the acceleration in the y direction, or the acceleration caused by gravity, of course, has to be a positive sign because I'm accelerating, I'm speeding up and speeding up and speeding up as I fall. Conversely, if this ball is kicked vertically upwards, it will start very fast and then it will slow down and down and down. So the acceleration here is negative because acceleration is also a vector. It has a magnitude and a direction. The direction is denoted by the sign. Positive sign if you're speeding up, or negative sign if you're slowing down. How do I calculate weight? It equals the mass times the acceleration caused by gravity. On your exam, if you have a calculator, use 9.8 meters per second squared as the number for G. But if you do not have a calculator, you can approximate G to 10 meters per second square and you will get an answer that is very close to the correct answer, because a difference of 0.2 is nothing to lose your friends over. Next, mass versus weight. Mass is also known as inertial mass, by the way. Not that you care. Mass is a scalar physical quantity, has a magnitude only but no direction. As for weight, it is a vector, meaning it has both a magnitude and a direction. Mnemonic: mass is scalar, but weight, which has a W or a double V, is a vector with a V. Next, mass is a fundamental physical quantity that cannot be derived from anything else. However, weight is a derived physical quantity. It is derived from mass and acceleration caused by gravity, so it's a derived physical quantity. How can we define mass or inertial mass? It is the amount of matter in an object. It's a measure of inertia. Okay. Is it easier to push a light box or a heavy box? Of course, it is easier to push a light box because the heavier box is gonna resist me more. So mass could be defined as the resistance of an object to change in kinematic state. What does that gibberish even mean? It means that it's harder to push a heavy box compared to a light box. How can we define weight? Remember that weight is a type of force. It is the force of gravity acting upon a body. Mass does not depend on gravity, but weight does depend on gravity. As you see here, it is multiplied by acceleration caused by gravity. On Earth versus on Moon, your mass is the same. If your mass is x on Earth, it's going to be the same x on Moon. However, your weight is different because your weight is dependent on gravity, and gravity is not the same on Earth versus Moon. The gravity of the Moon is about 1/6 that of the Earth, and therefore you are lighter on Moon compared to Earth. Your weight is less on Moon than Earth. Since the gravity of the Moon is 1/6 that of Earth, therefore your weight on Moon will be 1/6 of your weight on the surface of Earth. What's the measuring unit for mass? Kilogram. What's the measuring unit for weight? Newton. Remember that 1 Newton is about 1/10 of a kilogram, so a kilogram is larger than a Newton. How do I remember this number? Easy. Recall that G is about 9.8. If you use your calculator to calculate 1 divided by 9.8, you get this number, or very close to this number. In other words, you have to multiply the mass by about 10 to get 1 Newton. If you multiply 0.1 by 10, you get 1 Newton. On the surface of the Earth, each 1 kilogram has a weight of about 9.8 newtons. How did you find this out? Easy. 1 kilogram, you put 1 kilogram here, and then you multiply this by 9.8. 1 times 9.8 will give you 9.8 newtons. According to Newton's second law, F equals ma. If you multiply each side by a, you will get exactly this. F equals ma. Alright, how about weight? F equals ma. But since I'm pointing downwards towards gravity because I am weight, it's called F sub g. And instead of ma, this is mg. What is a? Acceleration. How about g? Acceleration caused by g, gravity. Earth versus Moon. The gravity on Earth is 6 times the gravity of Moon, so to speak. And the gravity of Moon, of course, is about 1/6 of the gravity on Earth. Meaning that if your mass on Earth is x, your mass on Moon will be exactly x, because mass is independent of gravity. Mass is a fundamental physical quantity. Mass is a scalar. But when it comes to your weight, that's different. If your weight on Earth is 100 kilograms, your weight on Moon will be 1/6 of that. 100 divided by 6 is about 17 kilograms. For those of you who are squeamish, 16.6666667. Let's say that you are good at jumping and you can jump 1 meter high on Earth. So here is you before jumping, okay? And then you will jump like this, and we will measure the distance that you jumped, and this is about 1 meter on Earth. Alright, if I take that same person and ask him to jump on the surface of the Moon, he will jump not 1 but 6 meters, because there is less gravity to pull him down on Moon compared to Earth. Quick notes on the center of mass or center of gravity. Each object has a center of mass or a center of gravity. For example, if I give you a uniform sphere that is solid on the inside, it is a homogeneous sphere. What do you mean? Symmetrical shape and uniform density throughout the object. Okay, where's the center of the mass for this object? Exactly in the center, precisely in its geometrical center. All right. How about a hammer or an axe? Well, of course, the metal part is way heavier than the wooden part. So the center of mass will not be exactly in the middle of the object, but it will be closer to the heavier side. Okay, that's why if you put your finger here and try to balance the hammer on one finger, you'll find that the hammer is sliding to one side and not the other because this is heavier, which tells you that the center of the mass is not here but closer to here. How about a baby? Well, babies have bigger heads relative to their body. Babies' skulls are huge compared to their body. As you grow older and older and older, the ratio of head to rest of body decreases. And that's why the center of mass is not near the umbilicus. No, it's closer to the head because the head is heavier. If that same baby rose both hands above his head, now the center of mass will go even further up, because I am affecting the balance of the mass. What if we have three uniform spheres? Here is M1, M2, and M3. They have different masses. For example, this one has the heaviest mass. Where is the center of mass for the entire three objects? Is it here, here, or here? In order to find this out, you need to do this equation. So, to find the center of mass, you need to multiply the mass of the first sphere by the distance from the beginning, okay? Plus the mass of the second sphere with its distance from the beginning. And then you multiply the mass of the third sphere by its distance from the beginning. And then all of this is divided by the mass of the first sphere plus the mass of the second sphere plus the mass of the third sphere. If you do this mathematical equation, it will give you the distance from the beginning where the center of mass is located. So there is x upstairs, and of course anything is divided by 1. And there is x upstairs, x upstairs, x upstairs, but there are no x's downstairs. That's how I remember this. Here's a problem for you. If Raj has a mass of 50 kilograms and he sits inside a vehicle driving at an acceleration of 2 meters per second squared, what is the force of gravity acting on Raj? Please pause and try to solve this yourself. When in doubt, draw it out. Here's a car. Beautiful. Nice. And here is Raj sitting inside the car. Okay? Cool. All right. What is the force of gravity acting on Raj? What is this asking about? Force of gravity acting on means force caused by gravity. Oh, this is the same as weight? Exactly. And this is the unknown. But what do I know? I know the mass of Raj, which is 50 kilograms. I know that the vehicle is accelerating at 2 meters per second, and I know that the acceleration caused by gravity is 10 meters per second squared. I want the force of gravity, therefore which equation should I use? This equation. F sub g, which is weight, equals mass multiplied by g, which is acceleration caused by gravity. Here is a g, here is a g. Okay, what is the mass? 50 kilograms. Multiply this by 10 meters per second, because this is the g. 50 times 100 is 500 kilograms times meter per second squared, which is equivalent to 500 newtons, and this is the force of gravity acting on Raj, aka the weight. And this is your final answer. But why did the teacher give me the acceleration in the x-axis? In order to use you and confuse you. But this is irrelevant to solving this problem. And here is the same answer in color. If we're asking about the force that is moving you forwards, you can use this acceleration. But that's not what they asked about. They asked about the force that is caused by gravity. And for this, you use g, which is 10, not the 2. Please note that the person's weight is not affected by the acceleration in the horizontal direction. One has nothing to do with the other. Here is another one. A car was pulled by a force of 1,000 newtons to move it at an acceleration of 4 meters per second. Find the mass of the car and the weight of the car. Please pause. Okay, what should I do first? You should write down what we know. Here is a force of 1,000 newton, and this is to move the car at an acceleration of 4. So this is force in the x direction. That's not gravity's fault. And the acceleration here in the x direction is 4 meters per second. Okay? I know that F, according to Newton's second law, is mass times acceleration. So 1000 newtons equals the mass, all right? How much is the mass? No clue. Do you know the acceleration? Yes, that's 4. If I want mass, I divide each side by 4. So 1000 divided by 4 is 250 kilograms. This is the mass of the car. All right, how about the weight of the car? Easy. Now for weight, I want F sub G, which equals M times G. What is the M? 250 kilograms. We just found this out. Multiply by G. Let's make it 10 to make it easier. And this is 2500 or 2500 what? Newtons. So look, mass is measured in kilograms, but weight is measured in newtons. And on Earth, your weight is about 10 times your mass. Here is the same answer in color. Take a moment to pause and review. There is a difference between this and this. That's why you gotta be super careful on your exam. Put differently, you need to get your head out of your sphincter. Here is another problem for you. A force of 100 newtons acts on a body to change its velocity from 10 to 20 meters per second while moving a distance of 30 meters. Find the mass of the body and the weight of the body. Please pause. Okay, first, let's write down what we do know. I know a force is 100 newtons, and this is pushing the vehicle forward, so in the x dimension. I know the initial velocity, which is 10 meters per second. I know the final velocity, which is 20 meters per second. And I know the distance, which is 30 meters. Call it distance, call it displacement, I don't care. Now, how can we tackle this? You'll need to recall the 3 general equations of motion. So if I know the initial velocity, 10 meters per second, and the final velocity, 20 meters per second. If I know the distance, 30 meters, then I'm left with only one unknown, and this is the acceleration. So let's use this equation. So let's write this down. 2AD equals V final squared minus V initial squared. Let's rearrange the equation to keep acceleration on one side and everything else on the other side. So acceleration equals V final squared minus V initial squared divided by 2D, which means that acceleration equals what's V final? It is 20. Square it, 400, minus V initial, 10, square it, 100, divided by 2 multiplied by distance, or 2 times 30, or 60. So this is 300 upstairs and 60 downstairs. Cancel a 0 with a 0. 30 divided by 6 is 5, so the acceleration is positive 5 in the x direction. Meters per second squared, and this is the first part. How can I find the mass then? Well, you do have the force, right? Yeah, you know that force equals mass times acceleration in the x direction and the x direction. Okay, how much is the force? 100 newtons. How much is the mass? It is unknown yet. And how much is the acceleration? It is 5. We just found this out. Okay, so therefore, what is the mass? The mass is 100 newtons divided by 5 meters per second squared, which means mass equals 20 kilograms, and this is the first answer. If you know the mass, can you give me the weight? Sure, the weight is in the vertical direction. It has to be going downwards. Equals mass times acceleration caused by gravity equals the mass is 20, acceleration caused by gravity is, let's say, 10 instead of 9.8 to keep it easy, which means that the weight of this body is 200 newtons, and this is the final answer. And here are the same answers in color. Please take a moment to pause and review. Always, always, always understand the difference between force acting in the x direction to push something forwards and weight, which is a force acting in the vertical direction to pull something downwards. And here is another one. Please pause and try to solve this yourself. Let's go. A force of 50 newtons is needed to make a 10 kilogram box slide across a horizontal surface. So this force is in the x direction, and it's 50 newtons. The mass of the box is 10 kilograms, and it's a horizontal surface. Amazing, so there are no angles to worry about. And the acceleration of that box in the x direction is 2 meters per second squared. Calculate the coefficient of kinetic friction. This was the homework of the previous video. So let's draw the little box here. It is 10 kilograms. We have a force pushing it this way, and this is the applied force. How much is the applied force? It is 50 newtons. you're pushing it this way, and yes, the box is moving and accelerating, so it is opposed by a different force in the opposite direction, and this is kinetic force. Are these equal in magnitude? No. How did you know? Because the box is actually sliding, which means the applied force exceeds the kinetic force. Exceeds it by how much? By the magnitude of the moving force, or the net force, which means the net force equals the applied force minus the kinetic force. According to Newton's second law of motion, net force is just like any other force. It is mass times acceleration. I'm pushing the box in the x dimension. And what is the applied force, please? 50 newtons, okay? Minus, what is the kinetic force or kinetic friction? Well, it is mu k, which is the coefficient of kinetic friction, multiplied by the normal force. And what is the normal force? The normal force is the exact opposite of weight. So the normal force is trying to pull you up, and the weight of the box is trying to push it down. Of course, you know that weight is m times g, which means that the normal force is also m times g. They are equal in magnitude, but opposite in direction, which means I can replace this normal force with m times g. So let's do it. What's the mass of the box? 10 kilograms. Acceleration in the horizontal direction is 2, and then 50 newtons minus mu k, which is the unknown, multiplied by the normal force, I mean mg. How much is m? It is 10. How much is g? Let's make it 10 to make the calculations easy. So you know everything except this. Can you find the unknown? Sure. Let's bring this nonsense to the other side with a positive sign, and bring this there with a negative sign. 10 times 10 is 100 mu k on one side, like this, and it equals what? 50 newtons minus 10 times 2 is 20. 50 minus 20 is 30 newtons. Therefore, mu sub k equals 30 newtons divided by 100 newtons, or 3 over 10, or 0.3. And that's the final answer. And these are the equations that we talked about last time. Weight is mass times gravitational acceleration. Weight is trying to pull you down. It is opposed by an equal yet opposite force known as the normal reaction force, which is also mass times g. When the box is being pushed but still static, you can make this force equal that force. So the applied force will equal the static friction. And what is the static friction? It is less than or equal mu s, which is the coefficient of static friction, multiplied by the normal force. But if the box is actually moving, then one is winning. The applied force exceeds the kinetic, and the difference between them is called the net force, or the moving force. Kinetic friction equals the coefficient for kinetic friction multiplied by the normal force. Very similar to static, but this is equal and not less than or equal. Also, let's answer this question, which was posed in the previous video. During driving under normal optimal conditions, nothing wet, nothing icy, just driving down the road and everything is hunky-dory. The tires of the car are exposed to what? Static friction? Kinetic friction? Neither or both of them? Please pause and try to enter this. Well, you might say, oh, the car is actually driving. So the car is kinetic, so it makes sense to be opposed by a kinetic force. But that's not true, because the tires of the car that is moving are not sliding on the road. Instead, they are rolling. Sliding will be if this tire is not turning and not rotating, and the entire car is being pushed forward, as happens on an icy road before you end up hitting a tree. But under optimal conditions, the particle of the tire right here, which is hitting the road, is not gonna slide over it. Instead, it will rotate and another particle will take place, which means the tire is rolling, not sliding, and that's a big difference, making static friction the correct answer. Here is your homework. We have three masses connected together by a weightless thread. These boxes will move at changeable velocity by the effect of a force which equals 13 newtons that is pulling all of these boxes in this direction. Please find the tension force in newtons in the thread between box A and box B. Also find the tension force in newtons in the thread between box B and box C? Let me know your answers in the comments. You'll find the answer key in the next video in this physics playlist. I'll be so proud of you if you can solve this yourself. You can download my physics notes, general chemistry notes, organic chemistry notes, biochemistry notes, all kinds of notes on my website, medicosisperfectionalis.com. I help you learn, understand, and pass exams. Make sure to check out my other playlists. If you found this video helpful, please consider supporting my channel by buying me a coffee. To learn about your kidney functions, glomerular filtration rate, renal clearance, the micturition reflex, what happens in the proximal tubule, loop of Henle, distal tubule, collecting ducts, etc., download my renal physiology course at medicosisperfectionalis.com. There are more than 600 premium videos available on this channel when you click the join button and choose the highest tier. Please subscribe, hit the bell, smash like, support my channel on Patreon, PayPal, or Venmo. Go to my website to download my courses, notes, and cases, or if you would like me to personally tutor you. Be safe, stay happy, study hard. This is Medicosis Perfectionalis, where medicine makes perfect sense.